Hi, my name is Will Grease, and I'm a program manager on the Azure Files team. In honor of Ignite, let's talk about one of the key features that was released for Azure Files over the last year: the ability for an Azure file share to be domain joined to your on-premises Active Directory domain. This enables you to replace an on-premises file server with Azure file shares. This can be done in just 5 simple steps, and actually, only the first step is really required. Just like an on-premises server, the very first thing that needs to be done is to domain join your storage account to your on-premises domain. So let's do that. So here I have a storage account with a file share that I'd like to be able to mount from on-premises. To domain join this storage account, I'll open up PowerShell and I'll import the AZ Files hybrid module, which gives me the commandlets that I'll need to do the job. The commandlet that I'll use is the join AZ storage account commandlet. Just like a regular AZ PowerShell commandlet, I'll need to provide the resource group name and the storage account name on the object I want to act on, which in this case is this particular storage account. And the domain name of the domain that I'd like to be domain joined, the resource type that I want to create, which in this case is a computer account, and the organizational unit I want to put this object in. And just like that, I've domain joined this particular storage account. Just like my on-premises file server, before I can actually access this share from on-premises, I'll need to put a share ACL on either the storage account or on the individual file share. And when I do so on the storage account, that share ACL will apply to all of the shares underneath. In this particular case, I'll put it on the storage account level. I only have one share in there anyway. And I do this by adding a role assignment. So I'll add the role. In this case, I can search for SMB share elevated contributor, and I'll type my name. I could add a group here as well. But I'll type my individual user account and add that as a role assignment. Now that the role assignments have successfully been applied, I can actually mount this file share on premises. Before we do that though, I want to refer you to these links to our documentation, which will show you how to do everything that I just did in your own environment. Before mounting the file share, a best practice is to test the network connection to Azure Files. I can do that by opening up the PowerShell prompt and using the test net connection commandlet to do this test. The computer name parameter is the fully qualified domain name of the storage account, so storageaccount.file.core.windows.net, and the common TCP port will be SMB. As you can see, this failed for me. Like many of you, I'm on a network that has port 445, the SMB port, blocked. If this succeeded for you, you can be done. You do not have to continue further. But if this failed, we have an answer. And the answer is to create a private endpoint for your storage account. So a private endpoint gives your storage account a private IP address within the IP address space of a virtual network. This enables you to tunnel from your on-premises network into your Azure network, working around the port 445 issue. So to create a private endpoint, I navigate to the Private Endpoint Connections tab on the left-hand side of the screen. I click New Private Endpoint, and then I provide the information for the private endpoint resource, like the name and the region. So there's actually no requirement that this be the same region as the storage account. But in this case, I actually desire that. So I'll create it in France Central where my storage account is created. I hit the Next button, and I need to input the resource type, which in this case is the storage account, and the actual name of the storage account, and then the service that I want to connect to. The Configuration tab shows me the virtual network that I need to attach to, and it actually shows me another important item, the private DNS integration settings that you see underneath that. But for now, let's put a pin in that and go create the private endpoint. Click Create, and just like that, you end up with a completed private endpoint. I did speed that up a little bit, but it's actually a pretty quick deployment. These doc links will show you more about how to create private endpoints. Now that I've created my private endpoint, I'll need to set up the VPN tunnel between my on-premises network or workstation and my Azure virtual network. This is a rather involved process, and I actually don't need to do this for every file share. I can do this just once. But I'm not going to show how to do this in this video. Instead, I'll direct you to these links to learn more about how to set up either a site-to-site or a point-to-site virtual private network. But I just wanted to show I actually have done this in this case. So to demonstrate this, I'll go into my private endpoint resource, and I'll actually look at that IP address for my storage account. So let me just note that down. So I'll do the testnet connection again, and I'll instead supply the IP address instead of the computer name, and again, SMB, and you'll see that this time it actually succeeded. So that's exactly what I expected to happen, and so I know my connection is up and running. So you might have noticed that I used the private IP address of the private endpoint rather than using the fully qualified domain name of the storage account. The reason that I did this is because the name of the storage account will resolve via the DNS lookup to the public IP address for the storage account, rather than the private endpoint that we just created. You can see this by using the resolve DNS name commandlet in PowerShell to resolve the DNS name to a particular IP address. This is equivalent to NSLOOKUP on Windows or on Linux if you'd prefer to use that. And as you can see, when I did this resolution, I get back the public IP address of the storage cluster that hosts my storage account in Azure. I want to actually change this to point it at the private endpoint. So to do that, I have actually deployed a VM in Azure that will act as an intermediary between my on-premises domain controller and DNS server and my cloud private DNS zone that was created when I created the private endpoint. So I called it Cloud DNS. And as you can see, here's a remote desktop connection to my Cloud DNS server. You can see that I've actually installed the DNS server role. I didn't install anything else. This is the only thing I did before recording this video. And then over on the left-hand side of the screen here, I have my on-premises domain controller and my cloud domain controller. So I'll create a conditional forwarder on my on-premises domain controller for core.windows.net, and I'll point it at my cloud DNS server that I'm actually remoted into. As you can see, the validation of this IP address failed. Don't worry about that, that's expected. Now if I go to my cloud DNS and create a conditional forwarder there, I can forward the same name, core.windows.net, to the special IP address inside of my Azure VNet, which actually covers the default Azure DNS service and therefore the private DNS zone that I created. So I'll quick do a refresh of the cache to make sure that I respond back with the answer that I expect. I'll do a refresh of the client cache over here on my client. And now if I do the resolution of the name, I will actually get back the appropriate IP address rather than the public IP address. So you see that this resolves to the expected private endpoint IP address that I wanted. Before we move on, I'd like to show you the following resources where you can learn how to do what I just did. A common question that we get is why you have to use the fully qualified domain name of a storage account rather than some other name, like for example, the name of the storage account or an arbitrary name like an existing file server name. The reason for that is because we use the fully qualified domain name to actually find which storage account you want to talk to. You can see this through the following commandlet. So we provide a get az storage account AD object, which will get the object in your Active Directory domain, which represents your storage account. This object contains a property on it called the service principal name, which is used as part of Kerberos authentication to say which server, which resource you're trying to access. If I look at the klist or Kerberos list command, I can actually see that I've got a Kerberos ticket issued for this particular share. So when I access this share via File Explorer, Windows under the covers will get a Kerberos ticket for that name and pass it on via the SMB session to mount the file share. So now that you've seen why you mount the file share with that particular name, the next question that we often get is is it possible to use an alternate name, like, for example, an existing file server name, to mount the file share? And the answer is yes, you can actually achieve that with DFSN. So a reminder, this step is absolutely optional. If you want to just start using your file share, you can with the storage account fully qualified domain name. So this is really about taking over an existing on-premises file server name. So here I have my file share again. I've created a file on it since we last looked at this. And now I'm going to show you how to set up DFSN. So I'll go back to the main resource group, and you'll see that I've actually pre-deployed VM to be my DFSN server. And I actually have that open. So I can remote into this. You'll see that I've already installed the DFS namespace or DFSN server role to be able to act as an intermediary and take over my existing file server name. To make use of the DFSN server role to take over an existing file server name, I'm going to use a feature of DFSN called root consolidation. This feature is a little hidden. It's actually enabled via the registry. I have a PowerShell script that will actually set the registry keys that I need. So let me run this. And now that these registry keys are set, I can go and create a record for this particular server name, which happens to be called my server. And I'll assign it the IP address of this machine. And add host. Awesome. Done. And now I can configure DFSN to take over this name. So I'll add a new namespace. So I'll type in this server's name and click next. I will type in the old server I want to take over the name for, prepended with a pound sign or a hashtag symbol, depending on which generation you're from. I'll click next. I need to select a standalone namespace. The root consolidation feature only works with the standalone namespace option. Click next. And finally, click create. Now that I have my created namespace, I can navigate into it and create the folder target for my share. So I'll call this just simply share and add the path to my storage account, which can be seen with the fully qualified domain name of the storage account and the share. Now that I've done that, I can pull open my client-side file explorer and type in the name of my old file server, my server, and the name of my share that I want to access. And now you'll see that just like before, I have connected to my Azure file share with my old name, and I can see the file that I have in that file share. To learn more about how to use DFSN, please visit the following link. Using these 5 steps, I have replaced my on-premises file server with an Azure file share. If you have any questions about this, don't hesitate to reach out to us at azurefiles@microsoft.com, and we'll get right back to you. Thank you.